Welcome back. Let's continue with our lesson on the Pythagoras theorem. So in the previous lesson, we talked about the Pythagoras theorem. We said that for a right angled triangle, isn't it? The square of the longest side is equal to the sum of the squares of the other two sides. We said that for a right angled triangle, the square of the longest side, which is the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So now we're looking at the converse. It says that if the square of the longest side in a triangle, if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled. So like here we have our triangle ABC, meaning that if the square of B is equal to the sum of the square of C and square of A, then this triangle ABC is a right angle triangle. That's the converse. And then the reason you write, you say converse Pythagoras or converse theorem of Pythagoras. Right, for triangle ABC, if AC squared is equal to BC squared plus AB squared, or we say B squared is equal to A squared plus C squared, then this angle B here is 90 degrees. Then this angle B here is what? Is a right angle. Okay, so in triangle PQR, PR is 17 units, PQ is 15 units, and QR is 8 units. Show that triangle PQR is right angled and state which angle is the right angle. So now if we prove that the square of 17 is equal to the square of 8 plus the square of 15, then means triangle what? Triangle PQR is what? Is a right angle triangle, or angle Q there is what? Is 90 degrees. So we're going to do this. Let's have on the left hand side 17 squared, and then on the right hand side we have 15 squared plus 8 squared. Okay, and then if we check here, 17 squared is equal to 289. Then 15 squared plus 8 squared is equal to 289, meaning that the square of the longest side is equal to the sum of the squares of the other two sides. So now this triangle, we can conclude and say triangle PQR is a right angled triangle. Triangle PQR is a right angled triangle. Then we can write our reason, converse Pythagoras. Okay, all right. So we've proved that the triangle PQR is what? Is a right angle triangle. All right, in triangle ABC, AB is 13 units, BC is 5 units, AC is 12 units. And in triangle ACD, AC is 12 units and AD is 20 units. Show that triangle ABC is a right angle triangle at angle C1. After that, what is the size of angle C2? State the reason. And after that, calculate the length of BD. You can try to do this one before I show you. And let's do the first part, A. Show that triangle ABC is a right angle triangle. This is the triangle we're talking about, ABC. This is triangle ABC. Okay. Now, if you check here, the longest side is 13 units, which is AB. So we're going to square the longest side, and then we square these other two sides and add them. If the sum of the squares of these two sides is equal to 13 squared, then means that this triangle ABC is right angled. Let's just do that. So we have 13 squared there, and then 5 squared plus 12 squared, and then they are equal. You see that? So it means that triangle ABC is a right angle triangle. Triangle ABC is a right angle triangle. And then the reason we say converse Pythagoras. Okay, converse Pythagoras. And then it means angle C1 is 90 degrees. And then the second part, we're finding the size of angle C2. If this angle C1 is 90 degrees, what is the size of angle C2? So it means C2 also is 90 degrees because C1 and C2 are adjacent angles on a straight line. So this is the straight line, then common vertex, and then common side. So it's going to be like this, and then C2 is equal to 90 degrees, meaning that triangle ACD is also a right angled triangle. You see that? Okay. Right. And then we need to find the size of BD. We need the size of BD, which is this. But we have this, which is 5 units. So we can get this here. And then after that, we add CD and BC to get BD. Let's get CD. Now we know that triangle ACD is a right angle triangle. So we can say that AD squared is equal to CD squared plus AC squared. And the reason is Pythagoras. Okay. And then you can even substitute like this. Then you write this and you write your reason. It's fine. And then let's find CD. Here we can bring 12 squared to the left. Positive 12 squared becomes negative 12 squared here. And then we can square root both sides. And then we get that CD is equal to 16 units. Okay, but the question is calculate the length of BD. So we say 5 plus 16, so it meaning that BD is 21 units. Okay, right. And then the center of the circle is O. OB is 17 units, BM is 8 units, and OM is 15 units. Show that OMB is a right angle triangle. Okay, so OMB, which is this triangle here, OMB is a right angle triangle. Okay, right, so we have to square this longest side, and then we square this 15 and square this 8. So if the square of 17 is equal to the square of 15 plus square of 8, then triangle OMB is a right angle triangle. So let's just do that. Okay, remember that if the square of the hypotenuse is equal to the sum of the squares of the other two sides, then the triangle is what? Is right angled. We can even say if the square of the longest side, because before we prove that a triangle is a right angled triangle, we cannot say the longest side is the hypotenuse. We can only say it's a hypotenuse once we have proved that a triangle is what? Is a right angled triangle. So, and then we have 17 squared is equal to 15 squared plus a squared, or it's the same like what we did there. And then we have that, so meaning that triangle OMB is a right angle triangle at M1. Okay, so prove that OM bisects AB at M. So OM bisects AB at M means that M is the midpoint. Therefore, meaning that MB is equal to MA, right? But we need to prove that. We can just not just write A here. We need to prove that. So what we have, OB is 17 units, okay? So meaning that OA also is 17 units because these are radii. So OA, okay, at this point, maybe let's just emphasize it. Bisect means divide into two equal parts. If OM bisects AB, then AM is equal to BM. And then we have that right, M1 is equal to M2. M1 plus M2 is equal to 180 degrees because adjacent angles on a straight line. So it means M2 is also 90 degrees there. Okay. So OMA is a right angled triangle. Now, and then we know that OA is equal to OB because they are radii. Okay, they are radii. So it means OA is also 17 degrees. So now we know triangle OMA is a right angle triangle and OA is 17 degrees. We can find what? We can find AM. We can find AM. And then substitute there to the Pythagoras theorem. And then we transpose 15 squared. You see that? Then square root both sides. Then get that AM is equal to 8. You see that? Okay. So now we can easily see that MB is equal to MA. So therefore, OM bisects AB. Okay. OM bisects AB at M. Okay. Right. Let's do the. Okay. Oh, we're done. Thank you very much. We're going to meet when we do the next video.